start recording. So, hello there. Thank you for joining me.
Hi.
Uh,
Nice to be here.
Very well, very well. Let's start with the basics. What is your name and what do you do in general?
So my name is Ovi Stoica. I'm a software developer. Been doing that for 10 years. My main technologies are Clojure. I've been doing a lot of React and TypeScript in the past, but mostly Clojure these days, and some things also related with AI and how you would orchestrate AI workloads, preferably from the Clojure ecosystem. And aside from that, I mainly do all of that from Emacs. And I guess that's
Yeah,
pretty
yeah.
much it.
Oh, that's good. Well, of course, that's a lot already because we will
Yeah.
delve deep. Um, when you contacted me, you told me that you are working with Clojure, that you are a power user of Emacs. You use it for a lot of things. So I want to start with Clojure, and I think Emacs will follow naturally from that. Let
Yeah.
me ask. So, from somebody who is an outsider to Clojure, like, why would I want Clojure? Like, what is the appeal of this language versus the more popular alternatives?
Yeah. So I think the initial most felt improvement or feature of Clojure is immutability. You have other languages that offer this, but in Clojure it is baked in. So your basic data structures like your lists, your maps, your sets are all immutable, which means, and it's not something like, oh, the language tells you need to create a copy. Let's say whenever you add something or modify a data structure behind the scenes, a new one is created so that you are guaranteed immutability. Of course, there is an escape hatch for this because sometimes you want more performance with like mutating the same data structure. But yeah, and how this happens, let's say you have your basic map, which is key value dictionary, and you want to add a new key and value to that. You would do that using a function called assoc. And that function will actually sorry for that. That function will actually, behind the scenes, create a new map, which will share structure with the original one. So you can think about it like I like to think about it like a git diff of the original one with the added things so that it's memory efficient. So you don't create a full copy, but it shares structure with the original one.
Mm-hmm.
And these are called persistent data structures, and they are implemented with trees. I don't know the implementation, to be honest. So that's as far as my knowledge of the internals go.
Uh-huh.
But so this is one thing, which is it provides a lot of benefits, which is immutability by default. But then you can opt out of it for cases where you need it. So it's a mix between immutability, the safety of immutability, but then it differs from things like Haskell or like the pure functional languages, so that it allows you to be hacky and do the performance things that you need when you need that. So it's a pragmatic functional language. I think Emacs Lisp is similar in this manner, but it differs from the fact that Clojure has by default immutable data structures, where I think Emacs Lisp doesn't. Second of all, it's a Lisp. Now, depending from where you look at this can be a pro or a con, and everybody that I showed Clojure to has the initial, so many parentheses, which is false, by the way, because you can even argue that there are less parentheses than in a C-like language. But that is the initial reaction for most people. But the advantages, of course, are that your language is homoiconic, which means that the language itself can be self-described in the same syntax, which allows you for powerful macros. Basically, let's say in a language like Python, you maybe want a new feature in the language. Things like the recent, let's say, with resource where you open a handle to either a file or a connection, and within the same scope, it will be closed at the end. So this thing for C-like languages is designed by committee and then shipped in the new version of the language. But with a Lisp like Clojure or even Emacs Lisp, you can basically write that macro yourself and use it as a function, as a language feature. That's almost indistinguishable from the core language. I guess comparing, and this is only from the accounts I've heard, so it's not my experience, but comparing it with the other section, like with Common Lisp, which is another popular Lisp language, the people I've spoken to say that every Common Lisp repository or project is different in as everybody writes their own sub-language in Common Lisp and they use that. So it's, let's say you don't have high transferability of knowledge within those, but in Clojure, people tend to use the standards of the language. So you don't, macro usage is not discouraged, but the philosophy is use only when it is highly recommended. You shouldn't use a macro just to be fancy, let's say.
Yes. And that, I think, is a sound advice, because exactly if you have your own mini language, domain-specific language, as they call
Yes.
it, in every program, then, of course, you ultimately don't know the language. You have to study every macro.
Yes. And I would say maybe the last piece for Clojure is very good concurrency basics. So Clojure comes with features for concurrency that make it be very useful in this domain. So you can do highly asynchronous and then concurrent programming with the safety of knowing you're not going to build food guns because it has good directives for this type of operations. Whereas, let's say in Java, where, by the way, Clojure is a hosted language. It works on the JVM, so you have access to the entire JVM ecosystem for primitives and popular libraries and things like that. But in Java, to do something equivalently concurrent as in Clojure, you would basically have to read 2 books on the design patterns and all of these things. So it's quite complicated, but it's way easier. And one thing which came out recently, and I'll briefly talk about it, is the creator of Clojure created a library called Core Async Flow, which is, Core Async is basically, the small explanation is like a very embedded pub subsystem. So you have channels on which producers put stuff and consumers will take it in an asynchronous way and thread safe way, you can say. And flow is basically a way to describe processes, asynchronous processes that communicate with each other through pure functions. And I personally used this system to build a real-time voice AI agent synchronization library. And it's so nice to be able to specify functionality through pure functions because you can test it. So particularly in this domain where you have AI, which I still view as highly unpredictable or non-deterministic, to at least have a ton of tests to that kind of make you safe that at least the orchestration layer I know is going to behave the way I want it, gives you a big certainty to release something like that into the wild.
Yeah, that sounds powerful. There seems to be, from the outside, because I don't know the implementation details and the technicalities, but it seems like this asynchronous feature and the immutability, they go hand in hand. It's like one feeds into the other.
Exactly. Given that you know that any change will be immutable. So let's say one thread will change or update a data structure, you know that the updated version will be a different one. So you know there's not going to be conflicting writes into the same data structure, let's say. So and that gives you the entire brain part, which you think about, oh, but what if this thread does this and I need to lock this resource? It's gone. You don't have to think about that, and that's great.
Yeah, because otherwise you have to think in terms of who edits first and what happens, and it's
Yeah,
really unpredictable or cognitively burdensome.
yeah. But of course, you have things like thread shared resources which are like updated, because sometimes you want, let's say, three threads sharing something, and that's called an atom,
Hmm.
which is like a, you could think about it like your mute kind of mutable variable in a thread safe way. But how it's done, it's not done through a mutex that a thread says, okay, I'm locking this resource, please everybody else wait until I finish my business with it. They do compare and swap. So it's like, this thread will give me the current value of this thing. I will apply a function that updates that value. And when it tries to put that back in to the atom, it will say, is the current value in the atom the same one as the one that I took when I originally took this value? If yes, means nothing changed, so I can update it. If something changed, meaning there's a new value, I restart, I recur, and okay, let's try with this new value, apply the function. If now it's the same, I'll update. So it's compare and swap.
Yeah,
And
yeah.
yeah, again, it's very pleasant to work with. Of course, maybe people not in the functional world don't know about REPL, but you also have a REPL, which is um, you get to evaluate from your editor functions and values to see the current behavior, and is this very pleasant way of doing interactive development, so at every point you know what your code will do, as opposed to languages that have a compilation step or things like that. You are of course aware of this, and this way of writing code, because Emacs is the same. Emacs itself is a REPL.
REPL, yeah. So for somebody who doesn't know, you just evaluate a function, you just see a variable's value right away, and you don't have to wait for the compiled code to show you what it is doing.
Yeah, exactly.
And
um
that, of course, speeds up the development considerably, right?
yes, it, I would say, maybe sometimes you see a drawback with this, where some code makes sense if you evaluate it step by step, but on the initial reading of it, it's hard to fully follow it, let's say.
Hmm. Hmm.
So I've seen this from time to time, but in Clojure, people, especially as your code base scales, people start to use schema libraries. So things like, I expect this function to take a data that has this form, which is a map with these keys and these value types for each key, and I expect it to output this type of data. Of course, so Clojure is still a dynamic language, so you can put type hints,
Hmm.
and you can use this schema-like behavior whenever you want to, let's say, simulate static type languages. But and this is something that I also did in my projects, and it's very nice. You can put, let's say, development flags. So check the schema for these functions when you're locally developing, but in production, because that's a performance overhead, disable that, because you,
Hmm.
let's say, tested all of those cases locally.
Okay. Yeah, that's a good flag to have. So you can have all the schemata locally. You make sure your code does what you want it to do. There are no surprises. But then in production, you just remove that check.
Yes, exactly.
But it's still dynamic, and you still have the schema there. How does that work? Like, can you enforce it? Can you basically make it strongly typed, kind of thing? Like,
So strongly typed in terms of at compile time? No.
mhm,
You can enforce a schema at runtime. So
mm,
you can, at execution time, basically when it takes a input, your function takes an input, it can check, is this the input, uh, is it conforming to the schema that I specified? And if not, throw an error. But yeah, at compile time, no. At compile time, you have things like check the arity of the function. So if you call a function with multiple arguments, more arguments than it expects, then it will throw at compile.
Yes. Okay. Yeah, that's good. Yeah. So where is Clojure mostly used, and where it would basically not be a good idea to use it, like broadly speaking? Like if I am a
Yeah.
programmer wanting to get into this domain, like what should I have in mind from somebody with more experience like you?
So I think one of the domains where it's highly used now, it's in the financial domain, because so the creator of the language, Rich Hickey, after he created the language, he also created a new database, which is called Datomic. And what is great about Datomic, it's a entity attribute value type store. So you can think about, and of course, if Clojure people are listening, I'm not a full expert on Datomic. I know my way around it, but I might make mistakes. So please in the comments if you want. But
No problem.
you can think about it as just a transaction log. So everything in Datomic, you can think about it as an array of transactions, and each transaction is you added this attribute to this entity with this value, and this is the transaction ID where this happened. Basically, what this gives you is a bitemporal database. So here's the greatest example is, let's say we compare an SQL database for a library, and in that library, in that like a book library I'm talking about, and say you have tables for books, for clients, for authors, whatever. And let's say you are a client and you borrow a book. And for this, in a normal database, you would have like a table which would be client ID borrows book ID. And those would be foreign references to those two things. And let's say you return the book, and then in the future you get another book and you borrow that. In this table of borrowing, the new book ID will replace the old one. But the fact, and this is Datomic is a database of facts. The fact that you, from the date, I don't know, 2024 and until a month later, you borrowed Walden, that fact is basically lost in a SQL database by default if you don't have another log so that you are intentional about storing all of that data. With Datomic, there is no such thing as an deletion. There are only retractions, which is at this point you added to the log that I am reading this book, and at a later point you say now I'm reading this book. But you can query the database saying something like, query this database as of 2024 and tell me at that point what book was read. So it's a bitemporal database where you can go up and down in time to see the full log. So you can see why this is very useful in financial businesses, where you want the full log of everything that changed, what money went from where, and when did that happen, and what was the status at a particular time. So this is one advantage. And there is a company in South America called Nubank, which is one of the most, I think it's one of the highest growing banks, and it's fully built with Clojure and with this database Datomic. And there are more companies. There is a banking as a service company in the UK called Griffin doing something like that. And they are basically, let's say you want to start a bank, that means a lot of development. So they are a API for you to build your bank upon. So this type of thing. And also what is very nice in terms of developer experience with Datomic is the fact that in a normal database like in SQL, you would have a database server which would handle querying, writing to the database, ensuring transactions, and I'm not sure if it has more responsibilities, and query optimization, write optimization, these type of things. But in Datomic, those responsibilities are separated. This is one of Rich's, the creator's, I think, mottos, like fully separate, decompose. Design is basically decomposing to the base things, and only from that you can build. So he decomposed the database into multiple roles, like the part which I query data from storage, which is the peer, it's called in Datomic, and the transactor, which is only responsible for writing data. And what this gives you in practical terms, and I'll try to be just brief and finish about this, is that you can get the whole database as a value. It's from the peer, you get a snapshot of the database, and you can treat that as a pure value. So functions that use the database are basically pure functions. And that, from a usability perspective of a developer, it's just miles away in developer experience, because you can just get a snapshot and just say, yeah, I'm working with this snapshot of the DB and I can make assertions on it. And that's whereas with SQL, at the start of the function, I can query these values, but I cannot guarantee that I'm going to get the same values by the end of the function.
Yeah. Oh, that's really powerful. Yeah, I didn't know about that aspect of Clojure. So, of course, I knew the language features in the big picture way, but now this really substantiates them. It's like, okay, yeah, now, of course, there is this system-wide synergy.
Yes, yeah, exactly.
Mm-hmm.
And it's very powerful. So it's in the financial industry. I think it's also most programmers that do Clojure is not the first language that they land on. It's most of the time it's grizzled developers that are like grumbling, I'm sick of all these languages, and they eventually land in Clojure, and this is where they find a home, let's say. So it's most of the time it's experienced developers coming to it. So it's also used in some startups, but there is this thing with Clojure where you truly have an initial setup cost. Like most popular languages have like what you would call either have like a Ruby on Rails type of thing where you have pre-built components, applications, things like that you can immediately just put into your startup or project and ramp up. But with Clojure, and this is the core philosophy of the languages, libraries over frameworks. To build something, you should just choose libraries that just do one thing and compose all of those together to get your final thing, which is great. It's very good that it does that, because it gives way more control back to the programmer, but it has an initial setup cost. And in a business perspective, where you want to move fast to prove possibly a theory about a business opportunity, if it takes you 6 months to set up your MVP, it's going to be too long. And somebody using TypeScript will have the same thing, the same base in 2 weeks, either because they have a lot of examples, or they can use AI to generate that boilerplate for them. Short plug here, I build a boilerplate for Clojure specifically to reduce this initial setup cost, which is quite substantial. So it's shipclojure.com, and you can check that out. But yeah, I think this is
of course you can tell me a little bit more about that, but continue on this line of thinking, and then I will ask you about ship Clojure.
Yeah, so let's say if you compare Clojure development time, let's say feature development time, to other languages, there is an initial high cost of setup, but then once you have everything set up, your feature development actually decreases with time. So you develop things faster because you have more tools at your disposal available in the repository. Whereas, and this has been my experience with languages like TypeScript or Python, you initially go very fast, but then you actually plateau, and your features develop way slower because you incur technical debt, and you maybe use libraries which are pretty much black boxes that you don't really understand. One perfect example here is ORMs. So it's like ORMs are object relation mappers, which transform database tables into objects that you can use in the language. But many times the inside implementation of this either gives you very slow queries, or when you want to do something very, very custom, you won't have the ability to do that, or you need to spend a lot of time understanding the internals of this thing that you're using. And yeah, Clojure devs are highly allergic to, like, it's this thing that does this magic and you get the result. Like, that's gonna be like, how does that work? Please show me the code. So that's one thing. Like yeah, high setup cost initially, but then you move very fast. Let's say 1 year in, 2 years in, and so on. So yeah.
And basically, the technical debt you are incurring with those other languages that are easy to start with or fast to start with is exactly the cumulative opacity of all these black boxes, basically. Like, you don't understand what this is doing, you don't understand that, this, that, etc. So, of course, eventually you need to figure them out or invent your own on top of what you are using.
Yeah, I would say, so I'm speaking just for the JavaScript ecosystem. There has been, in my opinion, a consistent infantilizing of developers, because there are multiple companies that offer developer tools, and basically their livelihood means that you need to use those libraries. So things like authentication, database management, emitting hosting, like very easy hosting providers, which all of these things are very nice and good. And of course, once you get to something like enterprise level, you need highly advanced authentication flows like SSO and all of these things, and security. But I think these companies, as they were promoting and saying, their message was for authentication, let's say, authentication is so complicated, you shouldn't bother yourself with it. Just use our product and that's it. And I see now that many developers are actually scared of doing authentication on their own. Sometimes it's good reason, like you shouldn't waste 2-3 months if it's an MVP building authentication, because that's precious time. But it should still come be within reason that authentication is not this very hard beast that you cannot tackle. So I see this happening, and if you actually go into the details of those areas of development, authentication, database, and deployment, you will find that it's not really that hard to do on your own, or like to research and learn. It takes time, of course, it takes time, but you should not be afraid of them. It's what I'm saying. And for hosting, for example, there are a lot of stories with Vercel. Vercel is the most popular hosting for JavaScript, and particularly for Next.js. And if you don't understand that thing correctly, basically each page that you serve, it's kind of like a Lambda page, and each image that is served goes through a Lambda that resizes the image to be web friendly, which is a very good thing to do. You should have that to not make people on mobile download images that are 5 megabytes, for example. So that's very good. But if you scale or have a DDoS attack or things like that, all of those functions being called, they will kill you in billing at the end of the month. So these are the things people should understand when they use these things. And this is what I mean by underlying magic that just happens, but you don't know what happens. And there are stories of people getting a $50,000 bill because, well, they got something very popular on Hacker News or things like that.
Sounds right, yeah. So tell me about ship Clojure, and specifically what it is fixing. Like, what is the upstart cost? What is the delay? Like, what are you helping with?
Yeah, so ship Clojure offers authentication and authentication pages, authentication flows like sign up with Google, reset password, reset password from settings, some starter settings if you do a web SaaS application, like settings pages, dashboard pages, a UI system, the backend, like how to do protected APIs on the backend. Database setup, there are two stacks, one with Postgres, so one with SQL, one with Datomic for people that have preferences in either area. Deployment support, so it has documentation on how to basically deploy to your own servers with using Kamal, which is a tool that helps you deploy Dockerized applications with zero downtime. So it has this proxy in front of which whenever you deploy a new version in a container, the proxy will issue health checks to it. And once it's healthy, it will start directing traffic to that one from the old one. And only then, I think this is called a red-green deployment strategy. So that also UI. So I didn't touch on this, but so Clojure by default it works on the JVM, so it's on the Java virtual machine. But there is also a dialect of Clojure, which is called Clojure script, which it's Clojure basically, but it compiles to JavaScript. So people write web apps with this language. And a very big advantage is that, so a normal Clojure on the JVM is going to be .clj file, and a pure Clojure script file will be .cljs. But many times you would have things which are common between front end and back end, and those we call Clojure script common. So it's like .cljc. And here you would put like pure functions, business logic, and schema definitions, for example, which are shared by backend and frontend. So having this is very powerful. And ShipClojure is built fully with Clojure full stack. So Clojure script on the front end, Clojure on the back end, and a lot of CLJ common, CLJC. So all of the UI is built with Clojure script, which is also one of the things which has a high setup cost. Clojure script, while good progress has been made recently with additions to tools and documentation, I think it's still one of the things that takes a long time to do, particularly if you don't have a lot of front-end experience, to set up bundlers and how you deliver the assets to the clients and caching assets and all of these things which are covered in this. So basically, ShipClojure takes care of the auxiliary stuff that you need when you do a business, so that you can just simply focus on your business logic. And it has a lot of documentation so that you understand the system. It is, let's say, it has my decisions for code, and that's why there are two stacks. So at least you have two things from which to choose. And I would say I chose the most popular libraries from the ecosystem to build them, so they are up to standard. But yeah, that's pretty much what it is. There is a community, so once you buy one of the stacks, you get access to the Discord with everybody else that bought it, where there are questions and answers and things like that.
And what's the difference between the two stacks? Like one is more opinionated and the other more generic, that sort of thing?
No, so the first one is called ShipClojure Pragma. On the front end, it uses, so because the front end compiles to JavaScript, you have access to the JavaScript ecosystem. And in Clojure, there is a React wrapper, which is called UIX. And it's basically, you can write React with Clojure primitives, Clojure script primitives. So it uses UIX, a state management library called Reframe, which is also something more data-driven in how you describe, you dispatch actions and effects and these types of things. So actions are this, you describe them through data, saying, I want this action to happen. And an action can involve effects, which are the things that actually mutate or are impure, like navigation or popping up a modal or something on the application. So you describe effects in a data-driven way, which helps with testing, let's say. So Pragma, which is it's for like, let's say, practical or like moving fast, has React and Reframe, and on the backend has Postgres and Rated, which is like a routing library. I would say the benefits of this stack is that you have access to the React ecosystem, which is huge. So let's say if you need uh, tables, or there are now libraries to do Excel things, or UI libraries that you would need, you can access those. Um, the disadvantage is that it's very hard to test UIs, to write tests for your UIs. Most of the time, you would use a headless browser, so something like Playwright, which is basically it's a separate program that you write code for and say, go into the browser and click this button and expect to see this on the screen, or click this button, or go this through this flow and expect to see this and that. So that's how you test, which is, you can understand that this can have a bit of flakiness in the test, or false positive, because you spawn up a different process and it loads the browser, and who knows, maybe this browser does this and that. The other stack, and also this has, let's say, the disadvantage that you are beholden to React, kind of. So like if React, and this happened in the past, React broke their initial API to write to release hooks, and then server components, which is, I still don't understand them. So it moves fast, and you basically are building on top of that.
Mm-hmm.
The other stack is built with a new UI library, which is written fully in Clojure script, which is Replicant. And Replicant uses the first assertion that React. So React came with the idea, hey, how about the UI is a function of the state? So f of state equals UI, which is basically a pure function. And everybody was like, that's great. Awesome. Let's go with that. But then that wasn't delivered because you have component local state. And if you have component local state, so if I describe my UI as a tree, each leaf or thing can have its own little small state that is not the original state that I give as a parameter to my function that creates the UI. It's not a pure function anymore. So it has unknown behavior. Replicant still uses the same virtual DOM, which is like you compute how the DOM would look in memory, and then you go into the browser and replace the actual DOM with your virtual computation. But in Replicant, you don't have component local state. You have just the global state, and that provides you Hiccup. What Hiccup is a Clojure representation of the HTML, but it's data. So you can work with it, you can associate it, you can concat. It's basically a vector in which the HTML tags are keywords, which are the same as Emacs Lisp. So it's very pleasant to look at, and it's every function in Replicant is a function which you give a snapshot of the state, so you know that's a pure snapshot that won't change, and it returns Hiccup, which is data, and you basically can test it. You can say, I want this UI. Let's say in the test, if it receives this state, I expect it to output this. And comparing to the Pragma with the UIX one, it unlocked a new sheer amount of tests I could write for the UI to make it more secure. But now the cost of this is you don't have the React ecosystem. So many of the things that you would reach out for a library, you kind of have to write yourself. It's the one I prefer because most of the time I am comfortable writing those things myself. But let's say if you want to ship something next week and in your designs or your things, you see that you need things complicated, which you have a library in React to use, you would go to use that one instead of this one. But this one is, you can write a lot more tests for your UIs. And on the backend, it uses Datomic, which has the same principle, let's say, as I said earlier, that Datomic, you can, as a database, you can just use as a function, as a snapshot, and it's a pure value. And even your API handlers, so when I make a call to /user ID, I can treat that as a pure function also. And it's exactly what happens also on the backend. So those are the two stacks. One is like highly embedded in existing libraries and you use it to move fast and things like that. And one is if you have highly, let's say an example would be highly complicated UIs that you want a ton of tests for, and you are comfortable doing that, you should use this one. And it's my preferred one.
And it seems that if you are under immense pressure to deliver quickly, like you should go for stability basically, because what you are describing here, the replicant variant, the stack, is like you can reason about it from beginning to end, and there are no gotchas, as it were, in your
Yes.
stack.
Yes. There is a great talk about this, which is from the creator of Replicant, Christian Johansson, called Data Driven UIs, for people that are curious. And yes, exactly as you said, even the intents are described as data. So I'll give you an example. Let's say I have a button on which when I click, I expect a modal to show up. That action is also described as a data, which you can think about as an array, and the action is described as a keyword. I actually don't know if does Emacs Lisp have namespaced keywords? I don't think so.
No, namespaces. Wait, there are namespaces in the context of variables and functions, but not what you are
Something like
describing.
so, like a keyword would be username. In Clojure, you can put a namespace to that. So it's like the namespace is user/name. So the
Yeah.
keyword is user/name, and you can unify some keywords based on the namespace. So it's like all the keywords be holding to user, let's say. And the action would be something like alert/modal or something like that. So basically, once you look at the hiccup describing the UI, you can understand what it does. So yeah, it brings a lot more stability. The Pragma stack compared to just normal React by itself brings a lot of stability, but yeah, this is way better. But again, there is the cost that if you need to move very fast, maybe sometimes you will accept the trade-off that there might be bugs, but you have something delivered and you can fix it down the line. So
Okay, it's an interesting, decision to make, because of course you have to weigh the pros and cons of, okay, I can move quickly and break things and fix them later at the cost of longer term pain, or I can suffer some short term inconvenience at the benefit of longer term resilience. So it's a difficult
yes,
thing to balance, of course.
I think it depends on the context in which you are at. Let's say if you have competitors or there is a time sensitive opportunity, if you lose it now but you have a very stable thing that nobody uses, you don't gain anything.
Exactly. Yeah, of
So
course.
yeah,
So yeah, it depends. You have to check with your business. Very good, very
I
good.
think both like save you a big amount of time. Like I've been speaking with Clojure devs, and there was one person that told me, yeah, it took me like 10 months to launch this MVP, and they spent a lot of time on authentication and all of these things. And I was sad hearing about it. It's like, man, you could have maybe done that in 2-3 months if you just needed to focus on your business logic, and you have like, and all of the things I said, you own that code. So that is your code and you can read it and you can understand it. There is documentation for it. There is not like a black box thing that's somewhere else and it's complicated to understand. It's in your code base. You can change it however you want. And the how each library is composed together to obtain the final thing, it's described. So yeah, that's it.
Okay. So the users will have confidence that what they get, they can see it, they can inspect it. It's all theirs.
Yeah.
Okay, very good, very good. I say we switch gears a little bit because now I'm curious how all this relates to your Emacs usage, because you told me also you use Emacs for a lot of things. I imagine you code in Emacs.
I code in Emacs. Yeah, I do emails in Emacs. lately I'm doing my finances in Emacs also with using bean count, which is great actually. I love it. And it started, so I first came to Clojure and then from that went to Emacs. So I think Emacs in terms of developer percent is somewhere around, I might get this wrong, but majority of Clojure devs are using Emacs, but not a big majority, something like 40%, 45, something like this. And after that, it's split between IntelliJ with a plugin called Cursive and VS Code with a plugin called Calva. So, and of course, there is NeoVim with Conjure. Basically, these plugins, why would you care about them? Is that they give you REPL support for those languages in those editors. And I started with IntelliJ, and after I created my first project, which was Design Vote, of course, I did exactly this mistake, which was like I rushed into building something. It took me a year to build it, and then I found out people. Not that they didn't care about it, because I had users, I had almost 1,000 users, but the problem it was solving was too small for them to justify paying for it. So basically, they were just using the free tier, and that's it. So after I sunsetted that, I joined the company, and there, all of the Clojure devs, all of them, were using Emacs. And I heard about Emacs. I even tried to download it first, because in the first book that you read about Clojure, which is Clojure for the Brave and True, they recommend Clojure, and they even give you a getting started step by step how to set it up. But the key bindings are from the standard one, and it's too much. Nowadays, the updated documentation is, if you start Clojure and you don't know Emacs, don't go to Emacs, because you're gonna need to learn two things now. So
Yes.
so I was in IntelliJ, and I was seeing these very smart people all using Emacs, and I remember I was like, what is it about it? Because you see the window, and it's just code, and that's it. It's like all of this free real estate, and I was like, man, I want to do that. So I think I tried to start with Emacs like 5 times, and the 5th time it stuck. And I asked for the config of one of the guys there, just to like understand and copy paste stuff. Too hard, gave up. I think I did it one more time, gave up. And then I said, okay, do Emacs. This is Vim. I was using Vim key bindings. Cool. Okay. I think the first time I gave up on it, and then I went with it, and it worked. I worked with it for a month, maybe more. But then with Clojure, it was working fine. But then my immediate problem was I was also doing React and TypeScript, and there is a particular requirement for that where you need multiple LSP providers in the same buffer, which Doom Emacs was not giving you that from the start. You had to configure it, and there is a package for TypeScript coding. I forget the name, but it's like an all-in-one thing. It's not LSP through eglot or LSP mode. It's just, I forget, TS something. I forget. And it's Doom Emacs gives you the option, hey, do you want to use this or do you want to use LSP? And I tried to hack it and change it, but it was too much and complicated, and TypeScript was slow to develop, and I just gave up. And basically, that was the moment when I said, okay, from scratch. And that took like a lot of my weekends. And I finally wrote something. I read Mastering Emacs. Highly recommend that book for anybody that's starting out with Emacs, because not only does it teach you how to get started with Emacs, but it also teaches you why Emacs is the way it is. Because there are many things which is like, why Control Y? How is this? And basically for many of those things, the answer is because Emacs was first, and only afterwards did new editors which became commonly used. So that's why. And it was just awesome. So I created my first initial Emacs config after that and with that, but it was still using evil mode. And in the book, basically it says, hey, go ahead and use evil mode, no problem. But there is this thing that you're kind of missing out on, which is I don't know how to put this, like, because Emacs was built for the not modal way of editing and like your normal way of editing with like control and all of these things. So if you ever want, give that a try. And I gradually found myself staying more and more in the insert mode of Vim, evil key bindings. And then I said, okay, let me just try. And the memes were true. My pinky hurt. So my pinky hurt. I put it on caps lock and still my pinky hurt. But and I tried it once, didn't stick to it, went back to Vim to evil key bindings. Tried it a second time, again the same thing, and because I know it, I still had this calling to like go back, and finally it stuck, and now I'm full Emacs key bindings to the point where I am not comfortable in Vim anymore. Like I forgot some of the muscle memory. It's been 2 years now, I think. And related to like Emacs TypeScript React, like with JSX, which is like sugar syntax on top of normal JavaScript so that you can describe markup in JavaScript. That's not a normal JavaScript feature. So if you use normal JS mode, you don't get that.
Yeah.
You need to use three-seater and all of these things. So I actually wrote a guide on how to basically set up Emacs for modern TypeScript React thing, which is like still to this day the most read guide on my blog. Mm-hmm. But I really spent a lot of time on that, and it takes, because you need to understand LSP, three-seater, all of these things together, how to put multiple LSP providers in the same buffer, and a lot of these things. And this is mainly the reason why I switched from eglot to LSP. I see now, because I still follow from time to time the discussions on eglot, that what they use is like a proxy, which is a proxy server which kind of will capture all of the LSP suggestions from other providers, but behave like one provider when it interfaces with eglot, which I think is fine. I think should work, and I see people are happy with it. But I am still on LSP mode, and I silenced a lot of the things to the point where it's unnoticeable anymore. I use it to find references to things through Xref and like go to definition of something, and that's mainly the usage. And of course, things like errors through fly check to say, yeah, this variable here is wrong or something like that.
Yeah, because ultimately from an end user perspective, what you want is for it to work. Like you get your completions, you get your linting, you get your source navigation, you get all that. So whether it's eglot, via proxy, or LSP mode, ultimately doesn't really matter.
Yeah, I think there is like many people, from what I see, still prefer that these things achieve that functionality through Emacs normal modalities. So like do references through through Xref, or show errors and things through fly check or fly make. I forgot which one is like embedded.
Fly make is the built-in, yeah.
Yeah, the built-in. Thank you. Yeah. And this sort of thing, because I also tested things like providers which are completely built their own thing. There is LSP Bridge, which the reason it began is basically super performant, because the Emacs has still this thing where it's single threaded and you need to parse, let's say, each LSP suggestion. And at the time, you didn't have the new JSON parser in Emacs, which made things very fast. But I still use, anyway, I'll get to that. But LSP Bridge is basically a completely separate implementation, and it uses, I forgot what this is, like the Emacs application framework, I think it's called so. So it uses that, but let's say the downside is that everything is custom. References are custom, search is custom, so all of this. But it's super fast, meaning I'm not sure if you ever look at NeoVim users when they have like autocomplete at their cursor, it's like lightning fast.
Yeah.
And with Emacs, you can achieve that, but you need to do a lot of work on your own to do that. But with LSP Bridge, you got that exactly the same feeling, but yeah, the cost is that everything else is custom. So maybe you have different key bindings for xref and find references in this thing. So eventually I just landed on LSP mode and said, this is a good balance for my needs.
Yeah, yeah, yeah. Me, I am somewhere in the middle in this regard. I appreciate doing things the standard way because, of course, you can reason about them and you know what to expect. But if everybody standardizes around something that is not necessarily optimal, ultimately we lose out on innovation. So having the option to do something out of the ordinary and maybe break a few things, but make breakthroughs in the progress. Of course, breakthrough, it's in the word. You break stuff, but you move past that and you find something new. I think ultimately that's good for the ecosystem. And then the best ideas, we then bring them in.
Yeah, that's true. I mean, and it is the ecosystem where most of the time people not default to but highly prefer to, I'm gonna build my own, and then if that becomes popular, it comes back in. So I think this is very good for innovation, let's say, and you can see this in with the new AI libraries. I stopped looking at them, but I had a period where I was highly not involved, but I was looking a lot at what new AI libraries are coming to Emacs and MCP, clients, and all of these things. But people move very fast with these things, and it's great to see.
Yeah, of
Um,
course.
yeah,
Now that you mention AI, you also mentioned it earlier in the context of Clojure. I believe in the context of audio communication. What was it?
yeah.
Yeah, so tell me a little bit about that. Like, what is this all about?
So this is it's a library called Simulflow, and maybe I'll give you a link to it. It's basically a orchestration layer to create a voice AI agent. So the pieces involved in a voice AI agent is, let's say you have your user audio, which would come from a telephony provider or a browser WebRTC connection or things like that, and it's in the format, it's let's say base 64 string or audio binary, and you feed that to a transcription provider, which is a commercial offering, and it gives you back text.
Mm-hmm.
From that text you feed to a text LLM, and it gives you back a response. That response, which is text, you feed to a text to speech provider, which is also commercial, so it gives you back audio, which you then give back to the user. This is like the very high level overview, and then you go into the details of this thing. So the library handles this thing with the capability of hot swapping providers for each of these areas, and handles the entire pipeline in a very efficient way, because the most important thing with voice AI is latency. So even in this conversation, you expect let's say it's called the golden standard. Let's say the two of us talk, and once I finish speaking, I subconsciously expect you to answer somewhere around within 700 milliseconds. This doesn't need to be like the complete answer, but something like for me to get the feedback that you understood what I'm saying, and you continue on that. So basically it's this 700 millisecond, you can call it a budget, right, for your entire pipeline to go through and the user to hear the first thing. So you need to optimize a lot. Like whenever your LLM is generating text, you get streaming tokens and you assemble the first sentence, and once you have the first sentence, you feed that to text to speech, and you basically send to the user audio while your pipeline is still going, basically, so that you achieve time to responses which are good in that area. And at some point you're still beholden to how fast all of these providers in sequence respond to you, like the time to response or time to first token is a good measure of this. And then you have other areas which are still in active development. One of them is turn taking, which is, and there are specialized AI models for this, or voice activity detection. Basically, turn taking.
Oh, sorry, I lost you. 1 second. This happens with Jitsi, by the way. I don't know what's the deal with it. Let me join back in. It has happened a few times already. Let's join. Hello. Sorry.
I hear you. Yeah,
uh,
it's okay.
it's a
Do
Jitsi
you hear
thing.
me?
Yeah, I hear you now. Let me kick out the old me. And
Yeah.
I see
Okay.
you now. So you were telling me about turn taking, and then it got interrupted. So yeah,
Yes.
please. Sorry about this. It's yeah, it happens with Jitsis. I don't know what, but at around the 1 hour mark or something, it decides to call it a day.
I see. So turn taking is in simple terms is like the most basic decision. Like user stopped speaking is saying, okay, the final thing was said 300 milliseconds ago or things like that. The user stopped speaking, and I can start generating an answer. But sometimes users have more nuanced takes on this. Like let's say I'm giving you a phone number, I may stop in the middle to remember the next digit, but your algorithm, if it's just time based, the AI will jump over you and basically interrupt you. So turn taking models basically take in and give you like a response from 0 to 1 in terms of how confident it is that you stopped speaking. And this needs to happen super fast. So this is a model that will run on the CPU, and it's a small model. Uh, these are also supported in the library. It's also interruption handling. So let's say as I'm speaking right now, you're going to say something maybe on a different topic. What you expect from me and what every human expects is that I drop what I was saying and what I was prepared to say to handle what you now started bringing up. So this also needs to happen, and it's quite complicated because sometimes maybe the user coughs or just says an and maybe you don't want to interrupt. So a lot of these, let's say, complicated decision making things, and also different providers, because these things need to be commercially viable for companies. I used to, like, in the last 1.5 years, I also did voice AI telephony agents for various companies, and this thing needs to be commercially viable, because if putting all of this together costs more per minute, let's say, than hiring a human, then it doesn't make sense to do that. So these commercial providers compete with each other on price. So when one is better, you would just want to swap out the thing, and you expect the whole thing to work the same way. So all of the providers that are built-in supported are easily hot swappable, and you can also bring your own provider with the how you would write it, and is there. This is open source on GitHub.
Okay,
But yeah,
I see.
that's basically what it is, and it's fully written with Clojure. Uh, because I don't like Python, and I don't like that ecosystem and all of the things, but like most of the time you would do something like this in Python. But to bring back the thing, like the biggest advantage I saw with Clojure was that, and that library I said about, is that all of these processors basically are, you receive a packet, you do work on it, or either send it asynchronously to something else, to another place. And it's basically, you receive a packet, you have some state that's a parameter to your pure function, and you expect an output. And all of these processors are tested in this pure function type of way. And it's very easy to reason about. And I think now the number of tests are around, not test, but assertion. So like the is this thing equal to that thing is around 3,000 for the whole
3,000.
library. Yeah,
Wow,
yeah.
yeah, yeah.
Disclosure there, some of the tests, not, I think somewhere around a third of them were written by AI. So that's a disclosure I can
Mm-hmm.
make.
Mm-hmm. So how is that workflow done? So when we say written by the AI, so to connect it also to Emacs, do you use something in Emacs for it to integrate with what you are doing, or are we talking about different things?
So I used to use a custom-made side panel agent, like how you have now in VS Code and all of these things, uh, with GPTel, and I made my own, and it would be like one per project. Uh, but now I use Cloud Code Emacs IDE, and this basically is I switched to Cloud Code some time ago, and there was another provider for like Emacs integration with Cloud Code, which essentially is just a vterm window with like a toggle side window on and off thing. And then it has on top of that an MCP from Emacs, which will always give it, all right, you are now in this file. It has access to fly check or fly make error report so that it knows when something failed from its behavior. And I also use Clojure MCP, which is basically the AI agent can hook into the REPL and basically issue commands to the REPL to test out the code that it wrote, so that basically it doesn't write blindly. And it also has, which is one of the most annoying things, it has tools. Clojure MCP provides tools for AI to write files or edit files, but it ensures it balances parentheses, because this is a famous problem now with AIs, that they will not balance parentheses, and when they try to fix that, they waste enormous amount of tokens to do that.
Mm-hmm.
So
yeah,
it balances that. But Cloud Code Emacs IDE is what I use now. There is another one which I use from time to time. I want to switch to it as my default one, which is ECA. It's Editor Code Assistant, and it's basically a JSON RPC based process which lives separately from your Emacs, which of course Cloud Code does the same, but then it interacts, it has a pure Emacs side window, so it's something based on Markdown mode. Mm-hmm. And it has clients for all of the other editors. It's very similar to LSP.
Yes, sounds like.
So where you have a server, and then you have your editor is the client for that server, and you stream responses and things like that. And it's open sourced, first of all, which is a big advantage. You don't know, Cloud Code is still closed source, so you don't know these things. And they support now, because one of my initial blockers was that you have a subscription to these providers like Anthropic, and you give $20 a month, and you have still limited usage, but I think it's better than pure API key based usage. But now ECA and other ones, I think they hack into the OAuth system so that you can log in with that provider to use the same benefits there. So I want to look more into ECA, but there were small things that I was too used to in Cloud Code that were disturbing my flow, let's say. So that's why I didn't make the full move yet, but that's like the target.
Yeah, I see. There is a lot of innovation on this front, and things are changing really quickly. So if you check out for, I don't know, 2 months and come back, it's like, what is happening here? I don't recognize most of this.
Yeah. I think it brings a lot of FOMO into it, like fear of missing out. But essentially, most of it is if you spend two days or 1 day exploring the ecosystem, you're gonna be up to speed pretty fast. Mm-hmm. I also noticed on myself, I recently don't use AI that much. I have this thing where I'm gonna do a confession now. So I was recently interviewing with companies for a job, and one of the companies gave me a hacker rank lead code type thing, and I was initially I'm gonna admit this. I was like, I'm gonna just use AI to do this thing because I can now. And the AI failed at the code. And then I spent like 10 more minutes trying to work with it to fix it, and it didn't. And then I was like, I'm just gonna do it myself. And I did it, and it worked. And then you have this thing where it's like, Jesus, AI made me almost to say lose confidence in my own abilities, so that I resolved to using AI for this thing, but I could have very well done it myself. And I was way prouder of my way of doing it. It's similar to the thing we were discussing earlier, like with companies
I was about
having
to
this.
connect to that. Yeah, the
Yeah.
infantilizing part you mentioned. Yeah.
Yes. And yeah, that started to ring some bells, some alarm bells for me.
Yeah, interesting that you mentioned that. So could it be that if we get used to working with that we lose a bit of our own edge?
100%. I did an experiment where I had an idea for a tool where the pitch is this: you're working in a project and you find a small little thing that's not fully related to the thing you're doing right now, maybe a bug or like a small improvement, but you don't want to take out the flow right now to focus on that. So let's say for me it was like an org file with to-dos, and it's like you put small to-dos in that org file, and every night or every predefined period, I was calling it the to-do goblin, which would be an AI would come, fetch a task, and open a PR with its attempt to fix that. And it was like, yeah, cool. And it's gonna be just small targeted things. I'm gonna review the code so I don't merge it by default. And I said, this is a perfect opportunity for me to do my first vibe coding experiment. So I did it. I talked with an AI, let full code this thing, and it failed at the end. The code was looking good, but when it was time to mix it, and like I had the part for reading the to-do tasks, opening the PR, calling an agent to attempt the code, and so on, but it failed. And the debugging experience was awful. I wanted to scratch my eyes, because you are now, your only ability now is to say, this doesn't work, here's the error, try to fix it. And the AI will say, yes, it's this issue, and it's basically lies. So you're just a middle manager, let's say. But you're also powerless now, because you don't know that code, so you cannot just go yourself into that code if you vibe code from the start, because it's like going into a new code base that you don't know. So the more you use it, the more you want to use it. So I scratched that whole thing, and I also wasted 2 days on it. And I realized that if I were to estimate this project on my own, just with my own abilities, I would have said that it takes 3 weeks, which would make me not even start at that point, because I had other priorities. But because I said I will rely on AI, I overestimated its powers, and it actually got me to waste 2 days. So my lesson from that was, I will never rely on, when I make estimations, I only rely on my own capabilities. And I think this is something that affects maybe the market in general, that middle managers and stuff. Yeah, but what if we use AI? Can we slice that cost? And I think no. I think you cannot do that yet. And yeah, to come back to the main discussion point, which was infantilizing and losing your edge, I think so, because in this experience I saw, the more I used it, the more I couldn't do it on my own. Or, okay, from a skill-based perspective, I could write that thing on my own, but I know realistically what it means. But in the code it generates, you are almost like your hands are tied. You cannot, unless you spend more days to fully understand what it did there.
Yeah.
So yeah, I think it's not a danger, but yeah, maybe in the future programming will be fully done by AI, and you are left just as a hobbyist if you want to do this. But yeah.
Yeah. For the time being, you need to know, because from what I understand, based on what you're saying, like the real danger is that you become a stranger to the code, which is in principle your code, your responsibility, but in
Yes.
practice, it's a foreign code base. Like
Yes.
you, because writing the code, of course, and the same it goes for actually writing down any idea. Forget about code, like anything you write, it's not just an idea in your head, it's something that now crystallizes, is elucidated. It's as if you can touch it and understand it in a three-dimensional way, whereas in your head is kind of 2D. And I think when you are writing code, you also understand the pathways to whatever conclusions or functions or whatever it is you are trying to express. And you lose that when somebody else does it for you.
You outsource the thinking. And I think, yeah, even in designing, people use it a lot now to brainstorm, right?
Mm-hmm.
To bounce ideas out of. But I think this also has a cost where if you were to just put your ideas on paper, and there is a, let's say, initial pain or initial struggle to just sit down and write your own thoughts and get into that flow. So there is a struggle there. Once you do that, you find ideas. Whereas if an AI will give you some solutions, even if then you say no, that's not a solution, it still anchors you in one direction for potential solutions. Whereas if you are clean slate, maybe you would have gone in a different direction. So I think it's like similar to how in negotiations when somebody it's called an anchor.
Yeah. You make the most maximalist position, and now whatever compromise is still on your turf.
Yes. I think there is this um, turning of the wheel in one direction that it will point you to.
Yeah, and actually, on this point, just to make a parenthesis here, of course, Lisp, right? Making parentheses everywhere. We can actually do this to ourselves. I have experienced this myself with taking notes or committing to projects prematurely. Like, oh, I
Mhm.
definitely believe this, and I write it down, and then I'm like, I will
Mhm.
work on this later. But I hadn't fully developed that thought, and now it anchors me in that premature
Mhm.
understanding of it. And I have to now undo that and then work on what I want to work. Whereas if
Mhm.
I let it develop a bit more in my head and then commit to it, now I don't have to undo any work and start.
Mhm. Mhm. And is the process of undoing it when you start writing it and you realize that okay, this is incomplete, or you face your initial hard struggle?
Yeah, it's like that. And this happens with coding as well, with programming. Like, if you don't have a very good idea of what you are doing, you write the code and then you're like, oh, wait, how am I supposed to flesh this out and connect it to a bigger workflow? And now you're like, okay, I have to go back to the drawing board, and you discard all the code. So
Yeah.
it's like that.
In the Clojure ecosystem, we call this hammock-driven development. So it's basically you develop by sitting in a hammock and just thinking about what you want to do.
I like that. I like that. Yeah, like in the previous Prot Asks I did, I also mentioned the hammock. Yeah, so I'm like, okay, yeah,
Yeah.
yeah,
Um, so yeah, that's yeah. The danger with AI is that I think, well, it's a way bigger but similar effect to what having a calculator brings you. Is like you have this super powerful thing that gives you the solution, but you lose on the but we lose the brain capability of doing complex calculations in our mind, which frankly I don't have that. I have that for like okay with like 2 3 digit multiplications I can do it, but over that not, but my grandfather can do them.
mm-hmm.
So I
Yeah.
think there is a similar effect here, and you can make the case, yeah, but the calculator unlocked new capabilities, right? Because you can do very complex things way faster. And the AI has the same thing, but yeah, I think, get way more comfortable to outsourcing your thinking to a machine.
Could it be that it's not the AI that conditions us to something that where we lose our edge, but our expectations of what the AI is doing or should be doing? In other words, could it be that I expect too much when it's not there yet? Like expecting a calculator to solve your math when it only does the calculation.
Yeah. I see what you mean. Just like if you use it like a very limited tool in its output or result, then it can be better used that way. And I think that's right. And a lot of senior developers use it fully that way, where it's like, I have this thing I have to write. I know exactly what it needs to be. I know for these inputs, it should output this. Please write it. I can write it myself, but it will take me 10 minutes to type it out. You can do it in 5 seconds. So let's say somebody put it, it's like mechanical work instead of thinking work, or like, knowledge work. So I like that, but I think it takes discipline to limit it to that.
Yes. And of course, the good scenario is that it does exactly the mechanical work. Let's say, write the function that you told it exactly to write. The bad scenario is that it does that, but in a way that it now reasons differently to what you told it, and you have to argue with it, basically.
Yeah. One aspect where this happened to me, and that's when I kind of stopped, was in tests. So I had pure functions for the library we previously discussed, and it was pure functions. I said, okay, here is the function. These are the cases. Please write tests for them. And what I discovered that the AI was doing is, if it finds that the pure function has some wrong logic in it, like some branches are bad, it won't stop and tell you, hey, this is wrong. It will actually modify the tests so that they pass the wrong logic. And I just stopped. I was like, these tests are useless.
Yeah, of course.
So, and I stopped doing it. But I think this is one of a great example to something that you were trying to showcase there.
Yeah, exactly. Oh, very good. Look, I pass all the tests. I'm so good.
Yeah. And
No, that's very nice. Because,
yeah.
of course, we also do, not me and you necessarily, but we also do this in our everyday life where it's like, yeah, let me just pass the letter of the stipulation, whatever it is, but otherwise I don't care about the substance.
Yeah, exactly. I mean, people do this all the time, where I broke some tests and I just skip them now or comment them out and problem solved. But yeah, I mean, like writing tests, I think is very powerful, and it also helps you, as you said, like further your line of thinking on the logic you are kind of testing, let's say, because now it's almost like, right, let's bring counter arguments to our initial assertion to see if it still holds up. So it's that kind of process, I think.
Yeah, of course, which then broadens your understanding of what you are doing, and you can catch errors in your own thinking.
It's almost never that I write tests and the initial thing that I'm testing stays in the initial form after the tests are written.
Okay, that's insightful. So the test is basically a way of self-reflection.
I would say
other than
so.
the actual testing that it does.
Yes. And people now say that AI is great for testing and actually for its own self-testing, where there are new techniques that people keep using, where it's like they say to the AI, here's your task. Please write some tests, like test-driven development. Please write some initial tests and then do the thing, making the tests pass. And I think that brings better results for them, as opposed to just one-shotting, meaning do the thing first try, no verification. But The cost is further down the line when your tests fail and maybe you go into the tests to fix them. It's foreign to you. You don't know nothing there. So it's again the same thing where it's not your understanding. You outsource that, so you are now dependent on the. It's like having a consultant come in and do the work for you, but then you're dependent on that consultant to fix things if further down the line you have issues. So yeah.
Yeah. Have you thought about the wider implications of this, like for the industry? Like, for example, how does someone go from being a junior to becoming a senior and all the intermediate qualifications if basically you never go through this grind? Like, how does that progression look like?
I have thought about this, and I have also, let's say, direct experience in the sense that I have a smaller cousin that wants to get into the industry, and I saw the initial doubt, which was he's in high school and he was like, I don't think I want to pursue this anymore because it seems that it's going to be replaced by AI. So why should I bother go to college for this? And my argument to him at that point, and I still hold this to be true, is you should still go to college, even in the worst scenario where AI will fully replace programmers and companies will not, let's say, allow you to code anymore, but just maybe oversee and think about design or things like that. Even in that scenario, you still have the basics of programming, and which also involves basics of logic and mathematics and some physics, because you do these things in college, which are good bases to have even if you do a domain switch. So I still recommend you do that. And it's also the fact that the best at this moment, the best people, the people which are best equipped to use AI are the people that understand what it generates. It can very easily trick you when you don't understand what it generates. So I think that's one thing, but it will 100% have effects on companies and people. And I saw many people. So one current effect that I see is, so some people complain, some developers complain that I hate my colleagues using it too frequently and too freely, and it puts work on them because now they have to inspect that what was generated is according to standards and all of these things. So, and this more generally, not to programming, was called, because there was a term for this, there's a term evolving for this, which is slop work or something like that, which is, I have a task to do, but I don't want to expend the mental energy to do it myself. I'm just going to put it on AI and just feed it forward, which is basically put the actual work of reviewing that thing on somebody else. The worst case of slop work that I've seen that became a bit viral was there was a clothing store, I don't remember the name, and they were having to do models wearing those clothes, and their AI models used Luigi Mangione, which is the guy that did an assassination in the US, as the model. It was a big scandal. And this is the example of slop work. And I think it's this thing where people gradually become lazy, and it is a bit in human nature that once you have it's very easy to go in comfort as opposed to in the struggle, in the thing that's hard to do but rewarding. So it's, yeah, if you view it just as a comfort creating technology, and it's not like a productivity boost, but more of a comfort because I don't have to expend the mental energy myself, but I can make it do it, it starts to be more real in that sense. Because I think if you put somebody who's fully focused and fully prepared and put them side to side with somebody that just uses AI, they would be I think, more productive, but it's harder to do. That's the main cost, I think, there. And yeah, there's gonna be costs to this further down the line, or like people fired or cultures built around it. But that's, I think, where I am as an opinion. I think it's like, for myself, I want to keep the discipline of coding myself, and fully understanding all of these things myself, because it's also what I like to do. When I'm using I am defocused. Because you start to wait for it, and you get on these, similar to how people were using on compilations. You lose track of time,
Yeah, yeah.
and then you get back. So it's the same sort of effect. There was a study on this, and they saw that when developers were using AI, they were recording their screens, and they were using their screens less, so they were more absent more time.
Uh-huh. Yeah, yeah, yeah. Of course, of course. Yeah, interesting, interesting. I don't know the answer of what the combined effect of all these is, but one thing is for sure is that basically it will be a different world, and people will have to adapt to it. And in a sense, it's more of the same. Like you already said it, like people tend to go for comfort. And in a sense, this is as old as humanity, just with
Yes,
modern means.
yes, and I maybe the answer, as at an individual level, is like, you just go and super specialize up to the point. I think this goes against modern advice now, but up to the point where you are really irreplaceable by an AI. Like, let's say, I don't think you could now go to do, like, people doing kernel programming. They don't use AI for sure,
Hmm.
I think, and other such, means. But if you go like super general, build web applications using React, that's highly replaceable.
Hmm.
So, and I think also, like, for programming, for people coming into the industry, if you really like it, you will find a way to do it. And because, and you see people who have a passion for programming, that like to code themselves, and people that just want to do the thing to get the job done. Those are the people that are gonna abuse AI.
Yeah, 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 of course. But of course, those who do that, in a sense, write their own conclusion to their career, because they are the one who will be the most replaceable. Like, if you are not sharpening your skills, like in conjunction with what you said, like the more specialized and irreplaceable you are, right? So if you are not sharpening your skills as you go, the more replaceable you become, effectively.
Right. Basically, what are the skills that a vibe coder with 3 years experience have over a vibe coder with 6 months experience? Maybe negligible.
Correct, correct, correct. Yeah, yeah, that's good. Just to say something on the topic of your cousin, um, something that I experienced myself, because me, my background is not in programming or math or sciences, none of that, is that once I got into doing programs, writing programs, all my other thinking, I think, benefited in the sense that I think in a programmatic way, like what are the requirements, what are the prerequisites, what is the preparatory work, how do we go from point A to point B in order to reach point Z, that sort of thing. Whereas before it was like, oh, I want to build a castle and it's up there in the sky, how do I support it, kind of thing.
Mhm.
Whereas now it's okay, let's do the support structure, and these are the steps, this is a scaffold, and there is the castle.
So you mean, by learning to code, you actually also start to learn a bit of project management, where it's like all the steps involved, and you can see like a concrete path to the end result. Whereas before it was just, I want to get there. What's the path? I don't know. Equals, I leave the thing because it seems too complicated.
Exactly, it's more aspirational. Whereas now with the programming mindset, it's more rigorous and more consistent in terms of, okay, these are the steps. And in a sense, you are now more confident that I thought it through and I can actually do it. And it has nothing to do with programming per se, like where I am now. I was like, okay, these are the requirements, this is the work, this is what I do, and you get the end result.
Yeah. Well, you are definitely right there. I think it gives you also, this could be anything, but programming gives you also the end result of the thing, which is like, I built this. This is something that I did, and I'm very proud of it. And it gives you confidence, like, okay, in the future, if I have a big endeavor I want to start, I at least have some references from the past that I am able to achieve something that I put my mind to, and I have steps to do it. And that's important.
Correct. Plus, if you have it out there as open source code, it's also something that others can go check and see what you did, and it's not just, oh, some magic happened and here is the result.
Yeah, exactly. And you can see like, oh wow, it's like 800 commits and it started at this point, and you can see every day the progress on the thing.
Yeah. I remember talking with somebody. I forgot who it was now, so I won't try to say the name. Where basically it was like, I think it was Rudy. But the point is that when you are reading somebody's code, you are effectively reading or getting insights into their way of reasoning as well. And so, of course, somebody who thinks clearly will write clear code, or anyhow, there will be some structure to it. It won't be haphazard.
Yes. There are caveats to this, meaning somebody who actually has the capability and the habit of writing very clear code due to maybe um, the pressures from business will write something very haphazardly. I
No,
like
that's always the caveat, yeah, of course.
so there's a funny thing here where is in the core namespace for replicant, the UI library we're discussing,
Mhm.
there is a documentation string saying, while you are reading this code, you may have questions like, why did he write it this way? Or why is this way? The answer is almost always for performance, or most likely for performance reasons.
Mhm.
And he admits that this might not look idiomatic or it's this way or that way, but yeah, the answer is because this needs to be highly performant.
Yeah.
So,
Which,
but
of
maybe this
course,
actually
no, please.
proves your point more, I would say, because yeah, okay, I get the reasoning for this thing.
Yeah, but also there is this other thing which I often point out, which is like, if you think more abstractly, what is the difference between a good student and the master of a given art, any art? In this case, replicant, let's say. The good student knows all the conventions, all the rules, this is how we go about it. The master knows all that, but also knows when that should not apply. Like, what is the
Yeah.
way out of that, when we should do the exception? And I think it's
Mm.
exactly that. I wrote this in a non-idiomatic way because that is the right thing to do in this specific situation.
Yeah. That's right. And sometimes maybe it's like, yeah, even if it's not performance reason, sometimes you're gonna say this is not the best way to do it, but it's not that big of a deal because it's a very, small, insignificant thing, and we have other more important things to do. This solves it without bleeding out technical debt into the rest of the project, let's say. So
Correct.
that's maybe another reason, like, or like another good example here is code duplication. Like, I think especially junior developers start to treat duplication as the word of law. Like, you never duplicate code, and this results sometimes in very clunky ways of doing it. Whereas sometimes you look at some code and know I have this in that other place, but the cost of me extracting this into one reusable thing will be so big that I just prefer to just copy paste it here and that's it.
Correct. Because then it's also not just a matter of correctness, but also of practicality, of time efficiency, of what are our other priorities in the job that we are doing. Like, if you do it in the most correct way, but you need to spend 1 month for it, it's ultimately wasteful when you could just copy paste and move on to the other thing.
Yeah, and I think it's also I think the moment you should abstract something into a reusable thing is when the cost of duplication becomes too high.
Mm-hmm.
But when you abstract that too early, maybe the two places where you have duplication are initially duplicating, but further down the line, you find this thing actually differs in this very small thing. So you just change it here. But when you abstract too early, now you need to change the abstraction to comply with this requirement. And now you basically introduced changes where they aren't required by default. So this is like one of the dangers with too early abstraction.
Yeah, from what I understand, basically the guideline is don't abstract too early.
Yes, yes. I think it's something that you start to develop an eye for with time, where you essentially burn yourself doing the coding commandments that you learn in, I don't know, your first course, or from your YouTube coding guru.
I'm curious if what we just said has any connection with what you said earlier about Common Lisp having all these macros, which everybody does things their own way. Could it be that part of those macros is an early abstraction kind of thing? Or am I now trying to connect things that
I am not
shouldn't?
sure. I don't think so, to be honest, but I don't know. I can only speak on Clojure macros, and most of the Clojure macros, some of them are compilers in their own, but most of them are something like with this thing binding, with binding, and it's like taking this resource and then by the end of it releasing it and using it in the body. Many are like that. Some are when you want the reader to not evaluate some code too early at, like, because function parameters are evaluated at the function like in the parameter section. So if you want a more lazy evaluation a bit later, like let's say you have some prints or whatever, you would use a macro for that. I'm not explaining this correctly because I have also some lacunes here, but yeah, something like that. But there are like super complex macros, like in Clojure there is a Go macro, it's called. It's go and like do some body thing, and basically what that does is take that code and put it on a thread pool of threads, and if there is a blocking part in that code, park it, and once it's ready, put it back on the thread to be executed. It's a way to do highly asynchronous work on a fixed thread pool. And that's like a core part of the core async flow, but it's a very, very complicated macro that it's essentially a compiler. It compiles that code into some code that you can put on threads and then park. But I'm not familiar with the internals that much. But to come back to your point, like too early abstraction for macros being too early abstraction sometimes. No, I can't find anything that matches that.
Okay, good. Yeah, because otherwise then you are shooting yourself on the foot with those.
Yeah. And it's also with lazy evaluation that you need to be aware of that. But yeah.
Very good. Let me ask you some final questions. Like, what is your outlook right now? So you mentioned ship Clojure earlier, but you also mentioned that you were doing this interview. So, like, what is your outlook for the immediate future?
So I'm gonna start a job now with a company doing Clojure, doing a SaaS-based Clojure project. The company is called Team Ohana, and my outlook is basically I want to improve as much as I can doing Clojure. I found that it's good to know yourself And I think I understood for myself, like, okay, at this point, I don't want to work in another language. Even if I'm highly competent in TypeScript, it just deflates me when I go into such a code base, because I know all of the rituals I have to do in order to code, and I don't like it. So I like building new things with Clojure. And it's this, the more you use a tool and you know the tool doesn't change that much, the more proficient you are with it and the more productive you are. So I think my outlook is to build cool things with Clojure, and in the process learn more about coding and development in general.
Hmm. And what do you think is the general outlook of Clojure? Like, are people more interested in it? Is there activity slash innovation? Like, what does the future of the language feel like? Maybe you don't know technically, but how does it feel like?
So it is not a big community. I think, let's say in the Clojurian Slack, there are around 30,000 coders. So you can generously say that there are a total of 40,000 Clojure devs at this point. There is innovation, there is new development, because again, there's this thing where you need something, you're just going to build it, and it's not that big of a deal because people are very productive in this language. So having something missing is not a big tragedy. Or you could just go into the Java ecosystem and pull it from there. So some people call it a parasitic language because it goes into an ecosystem and embeds itself there. In terms of, let's say, the future of the language, so this is interesting. So Rich Hickey, the creator, retired. So he's not doing as many appearances in conferences for other languages in, let's say, an attempt to presenting the language and make it known for other people. But Nubank, which is now a very big enterprise, I think is the biggest bank now in South America, is fully reliant on it, and it's too late to change. It's there to stay, and there are many companies for which it's there to stay. So Nubank actually now created a developer relations position, which is now occupied by Christoph Newman, and his job is basically making the language known to people, because essentially, in so many words, Nubank will need new coders to understand the language. And there are many big companies that don't bother to find existing coders anymore. They just find competent programmers and they teach them Clojure.
Oh, interesting. So basically, you just have to show that you are competent in any language, and then it's like
I think you need to also
maybe.
I think you also need to show willingness to learn Clojure. Like if you hate the idea of a Lisp, you probably shouldn't go there.
Yeah, okay, I see.
But for sure, I think the language is safe for now, and it will be. I mean, I personally don't want to use anything else, and it's my introduction to Clojure was I got approached by a company for a React Native position. So I was doing mobile development with React and TypeScript, and I checked the company out. And on their website, they had a full page dedicated to Clojure. This is a fairly big company. They had I think 50 employees. And they had a page which was like, we are committed to Clojure. And why? Because it has immutability and full stack and all of these things. But the thing got me interested because it was like, what's this Clojure thing? Like, you never see companies go, we are committed to Java, we are committed to TypeScript. You never see that. No. So that was my initial thing, and it gets you into the rabbit hole of watching the Rich Hickey talks and all of that. So I think you have a smaller ecosystem, but that ecosystem is highly loyal and they promote it whenever it's possible. Like, I don't talk about it to my friends that much because they're sick of it. Like at this point.
So you have already done it. You have already talked
Yeah,
with
yeah, yeah, yeah. And whenever we get together, they're like, "Ah, Jesus, those parentheses!" Like, I'm like, "Man, you should try it really." Also, just in the fact that you have structural editing, it's underrated.
Yeah, yeah, I think they are missing out in that regard. Like
Yeah.
somebody who is a competent developer of the sort you mentioned earlier. How is it for them to go learn Clojure? Is it something they can transition to and reason about, or will it be like hell? They will suffer through it.
How for me it was my personal experience. It's hard. It's a big ramp up, and it needs a mentality change. Because you cannot go what's the imperatively about a problem, like step one, do this, modify this, do this. You need to think about it, and like what is the final thing that I'm expecting out of this, and what are the transformations of data I need to make in between to get to that final result, and then you can, right? So it's a lot of that, adapting to like REPL driven development, to interactive development. And also there are some standards, because there is this thing with Clojure where all of the functions in the core library operate on multiple data structures. So I can use uh, uh, not reduce, but like I can use the same functions on a map, on a vector, or on a list, and they behave a bit differently. So you need to know how they behave, but essentially there was this line where it's like it is more powerful to have 100 functions operate on the same data structure than to have 10 functions operating on 10 data structures. So so it has this philosophy of it, and you need to put like for like functions operating on collections, you always need to put the collection last, and parameters, and these, so like you need to familiarize yourself with these development standards and with the ecosystem, because again, because it's the philosophy is one library to do one thing, similar to Linux, let's say, you need to learn a lot of libraries, or like what's the ecosystem and my choice for building a web handler or like a web server or things like that. So you need to learn a bit that.
I see.
So so I would say it's maybe minimum, I would say, is 4 to 6 months. If you have good guidance, so people that will help you throughout the way, I think it's faster. For me, I went about it alone because I learned it for my own project. But there is the Clojurian Slack, and people are very, very helpful there.
Yeah, it's also what you said, like they are really loyal and really going to be there for you.
Yeah, I mean, like the final example I'll give is like when I was doing this on my own, I had a very proeminent member of the community who basically built the SQL interoperability library, which is like how you interact with SQL from Clojure, is used by basically huge companies. And I posted a problem, and he was willing to sit with me and help me understand my issue, which I was like a very small beginner. And for me, that felt huge, honestly. It felt like a very big encouragement to continue.
It is, of course. Yeah, I mean,
Yeah.
that's not something you get elsewhere. Wow,
Yeah. Yeah. Yeah, exactly.
amazing. Very well.
Yeah.
I say we call it a day. We end our call here. Thank you very much for your time. I
It
learned
was
a
a
lot.
pleasure. It was a pleasure talking to you, Prot. And yeah, I hope we talk again.
Yeah, yeah, likewise, likewise. So I wish you all the best and good luck with all your endeavors, with your new work and with ship closure and with any other project you commit to.
Thank you, thank you. Same for you. And also, I want to say thank you for all of the libraries that I use from you. And also, like my full email setup is fully stolen from you. So,
Good, good.
and it's
Still
great, by
away,
the way.
still.
All
That's
right.
good.
Have a great day.
Take care, Avi. Take care. Goodbye. Closing the call and I will stop the recording.
Bye bye.
Bye bye. And closing. Take care, folks. Stop recording. Bye bye.